Hello and welcome to exam questions number 6 for permutations and combinations. I'm going to summarise the information as we need it, but if you want to read the question in full, please pause the video here. So we have the letters from the word probability written on separate pieces of card, and we want to find the probability that the two cards with the letter B will be next to each other if we pick them and lay them out randomly. Now, as we can see, probability has 11 letters, 2 B's and 2 I's. Now, if we were asked how many different words or letter arrangements we could make, the answer would be 11 factorial, and we would have to divide by 2 factorial, because there are 2 B's and 2 I's. Because, for instance, if we write probability, we could switch B1 and B2 and it's still probability. It's the same word. However, we are picking these cards randomly and laying them out. So if we picked B1 first and then B2, that's a separate event from us picking B2 first and then B1, two separate events. So the ways we can choose the 11 cards is actually 11 factorial. Now, if the B's are together, we can treat them as one unit. So we now have effectively 10 items to rearrange. And the ways to choose 10 items or 10 cards is 10 factorial. However, we could choose B1 first and then B2, or B2 first and then B1. So we have to times the 10 factorial by 2 to get the number of ways we can select the cards where the B's are together. So the probability of selecting the cards where the B's are together is 10 factorial times by 2 divided by 11 factorial, which reduces down to 2 over 11. Part B, we're asked to work out the probability that the two cards with the B are next to each other, but also the two cards with the I are next to each other. And to work this out, we group the I's together and treat them as one item. So we have effectively 9 cards to choose from. And the ways to choose those 9 cards is 9 factorial. However, as with the B's, you can also have the I's either way round. So we have to times 9 factorial by 2 for the B's and by 2 for the I's. So the probability is 9 factorial times by 4 divided by 11 factorial, which is equal to 2 over 55. And finally, we're asked to deduce the probability that the two cards with the B are not next to each other and the two cards with the I are not next to each other. Now, this is going to be easiest to work out using a Venn diagram. So if we label one circle B for the B's next to each other and one circle I for the I's next to each other, we can start filling it out with the information we know. Now we know the probability of the B's together and the I's together is 2 over 55, so we can write that in the middle section. And we know that the probability that just the B's are together is 2 over 11. So first we need to change it so it has the same denominator, which is 10 over 55. So if we know that the 10 over 55 is for the entire circle, then we just subtract the small portion that overlaps, 2 over 55, from it. So we know that we have 8 over 55 in this section. Because there are also 2 I's, we know that the number will also be the same in this section. And because we know the total probability has to be 1, then if we subtract these numbers from 1, we'll get the probability that the B cards are not next to each other and the I cards are not next to each other, and the probability is 37 over 55. So again, please pause the video if you want to read this question in full, but I'm just going to pick out the information as we need it. So we have 2 pegs of each of the colours red, green, brown, orange, pink and blue. Now we pick out one of each colour and we have 4 holes, and we choose 4 to go in these 4 holes. In how many ways can we arrange them? Well, this is the same as 6p4. We have 6 items and we're picking 4 to put in an arrangement. So we could use the permutation formula, and that gives us 6 factorial over 2 factorial, which is 360. Of course, if you wanted, you could say there were 6 ways to choose the first peg, 5 for the second, 4 for the third, and 3 for the fourth, and do 6 times 5 times 4 times 3, and you would get the same answer. Next, we're told we have 2 pink, 1 blue, and 1 green peg, and asked them how many different ways we can rearrange those. Well, we can rearrange 4 items in 4 factorial ways. However, it doesn't matter which way round the pinks are. It's pink 1 first and pink 2 is the same as pink 2 first and then pink 1. So we have to divide that by 2 factorial. So the answer is 12. And finally, we're asked how many arrangements are there if we pick 4 pegs randomly from the 12 available. We have the possibility to choose 2, 3 or 4 different colours within our selection. Now, if we pick 4 different colours, we've already worked out that there are 360 arrangements. But what if we use 3 different colours from the 6 available? We need to work out in how many ways we can choose 3 colours from 6. Using the combinations formula, we get 20. However, if we had 3 colours, such as green, pink, blue, we could have 2 greens, a pink, blue, 2 pinks, a green and a blue, or 2 blues, a green and a pink. So we have to times 20 by 3 to give us the amount of ways you can choose 3 colours. But then we need to find out in how many ways we can arrange these 4 pegs, which is 4 factorial divided by 2 factorial because 2 of the pegs are the same colour. So that's 12. Therefore, the arrangements is 60 times by 12, which is 720. And lastly, we work out the number of arrangements if we only have 2 different colours from the 6 available. So first we have to work out in how many ways we can choose 2 colours from 6. And using the formula, we get 15. And then we have to work out how many ways we can organise the 4 pegs, which in this case is 4 factorial over 2 factorial, 2 factorial, because 2 of the pegs are the same colour. So the answer is 6. Therefore, the arrangements with 2 different colours is 15 times 6, which is 90. Therefore, the total number of arrangements is 360 plus 720 plus 90. So it's 1170. Thanks for watching. If you look down below and just hit that little thumbs up button, that would be great. And I'll see you in the next video.